Hello, beautiful people, and welcome. In today's video, we are talking about complex numbers. Now, what are complex numbers? A complex number is a combination of a real number and an imaginary number. Now, that imaginary number typically has a multiplier of I next to it. So, for example, B, whatever value you have in the placement of B, that would be your imaginary number. So, for example, let's say we have 3 plus 5i. Your 3 would be real. Your 5 would be imaginary. Now, in order for this to be a complex number, we need an imaginary part. So therefore, b cannot be 0, because if we have 0, we don't have anything that's complex. So it needs to be greater or less than 0, but it cannot be 0. So what are we doing with these complex numbers? So we are going to be adding, subtracting, multiplying, and dividing these numbers using methods that we've learned before. Now, when you are dividing, we're actually going to teach you a very small different method of dividing, which doesn't really include dividing, but we'll see. All right, let's go ahead and start out by adding, subtracting. Before actually we do that, just a quick reminder of your imaginary unit, I. So anytime you get a square root of -1, that equals to I. Anytime you get I squared, that equals to -1. So you will be using these conversions. When you are adding and subtracting complex numbers, you are going to treat it as a variable. Treat I as a variable. As in, if it were x, if you had 11x and 4x, how would you combine them? Let's start off by writing these together. And I'm going to combine terms that are like, that are similar, by writing them together. And this one's addition, so we're going to have and 7, so 5 and 7. Now I have a -11, I. Make sure I has a little tail to it. And I have a positive 4i. Just like we would with variables, we have 5 and 7, so 7, 8, 9, 10, 11, 12. And we have -11 plus 4, which is -7. So we have 12 minus 7i. Let's do that again for subtraction. Now, with subtraction, make sure, just like when we were dealing with polynomials, that you are going to distribute your negative onto each term and then flipping the symbol. So what you really have is not a subtraction problem. You really have an addition problem that's kind of been hiding. So now we have a positive 11 and a positive 6i. Now that you have addition, just like we did in the previous problem, let's go ahead and combine like terms. So I have -5 and 11, and I have 1i and 6 i's. So that made me giggle inside. 6 i's, I have 6 i's. Okay, so I have negative, it should be a positive, right? Because -5 plus 11, that's a positive 6. And I have 7 i's. So 6 plus 7i is your complex number. Let me shift this up so you guys can see that. All right, moving on to the next ones. Let's talk about multiplying. And multiplying is going to be exactly the same thing that we did when we were multiplying polynomials, binomials, things like that. You have 3 methods. You can either distribute, you can FOIL, or you can use the box method. I personally, if it's not a monomial, if it's not one term that you are multiplying, I choose box method. It's just easier for me to kind of separate things out, make them nice and neater. So let's start here. So here I have one term that is being multiplied inward. Now when you're multiplying, it's a little bit different because you want to multiply things that are the same, just like when you were doing with variables. The i's go to i's, the numbers go to numbers. So I have 4i times 3, and this is a negative, 4i times 5i. So make sure that you have the numbers going together and the letters going together. 3 times 4 is 12. Bring down the I. Minus 5 times 4 is 20. I times I, just like x times x, that means I squared. Now this is our first time we're going to be using our conversion. we know that I squared actually means that you have a negative 1. So this entire I squared is negative 1. I like to put that in parentheses so I can make sure to multiply whatever that is next to. So I have 12I minus a negative 20, because negative times 20 is that. That means we have a positive. And I'm going to rearrange this so I have my number on top. Excuse me about that. So I have 20 plus 12I. Again, you make sure you have it in this format. I keep getting off screen. Sorry, guys. Let me shift this around. Make sure I have space. All right, let's do that one more time. This time we can either FOIL or use the box method. I mentioned before I prefer the box method, so I'll do that. I have 7, negative 3I, negative 2, negative 5I. And just like before, we want to make sure numbers go to numbers, i's go to i's. 7 and negative 2, that's negative 14. Here I have negative 2 times negative 3 times I. That means I have a positive 6I. Here I have 7 times 5 is 35, so 35I. Again, that's 7 times 5, negative, times I. And then this one here, I have negative 5I times negative 3I, so that means negative 5 times negative 3 times I times I. The numbers go together, the i's go together. It means I have a positive 15. I also have I squared. But again, anytime you have I squared, what do you have actually? You actually have a negative 1. So that means you have here a 15 times negative 1, which is a negative 15. So I'm going to highlight all of the numbers that we have to care about. So we have this negative 14, we have this negative 35I, we have this 6I, and we have this negative 15. So just like if it were a variable, we are going to combine things into a kind of like a polynomial, a complex polynomial. So I have negative 14 plus 6I minus 35I minus 15. It looks like it may be a binomial, not a polynomial. Shifting this paper up just a little bit, I have pre-circled our common terms here and also underlined common terms. So notice that you have 6 i's that are positive and 35 i's that are negative. That means you have a total of 29 negative i's. And here without your i's, you have negative 14 and negative 15. So therefore you have just a numerical negative 29 without an I. So your answer is a complex number with negative 29 minus 29i. Now, if you're thinking, well, both of these terms have a 29, can you factor? Sure, you can factor out 29. You don't have to. So you can factor out a negative 29 and have 1 minus I in your bubble or in your grouping. You can absolutely do that. Ooh, not negative I, positive I, because if you multiply negative 29 inward times 1, that's negative 29, and negative 29 times I, that would be negative 29I. So you can factor 29 out and leave just the bubble. All right, let's go ahead and move on to complex numbers and the conjugate of complex numbers. So we know that a complex number is, let me shift that out. There it is. We know that a complex number is in the form of a plus bi, or you can have a complex number in the form of a minus bi. Either or, one of them is plus or minus. Now, conjugate is a really fancy word. And I think the word itself sounds a little complicated, but I promise you it's not bad. Conjugate just means that everything stays the same except the middle term symbol, or the second term. The symbol is different. The middle symbol is different. So if you have an A plus BI, the conjugate of that, is a minus BI. And if you have a minus BI, the conjugate, let's see if I can spell it right this time, is a plus BI. So note, All you're doing, let me shift this over, all you're doing is changing the symbol in the middle, one from a plus, one from a minus. Now, when do we use this? We use the conjugates to divide. Now, how do you do that? Well, there's different ways. Let's do an example. Let's do 3i divided by 4 plus I. Now, you use conjugates when you have two terms. So you would not use conjugates if there was no plus here. You would just simply cross out the i's, but you cannot do that because of this pesky plus. So instead, what you're going to do is you're going to multiply top and bottom by the conjugate of the denominator. So if we have 4 plus I in our denominator, you're going to multiply by 4 minus I. Remember, the conjugate is just the symbol in the middle. That's different. Now, in our numerator, you have 3i times 4 minus I. In our denominator, you have 4 plus I, 4 minus I. Now, if you're thinking, wait, this looks familiar. This looks like the difference of squares that we did in our factoring unit. Absolutely, that's exactly what it is. So let's deal with our numerator first. Let's distribute that 3i. So you have 3 times 4 times I minus 3 times I in our numerator. In our denominator, if you recall, we had a squared minus b squared. Remember, a is in a bubble, b is in a bubble. And so what do we have here? We have 4 squared minus I squared. And that was from our factoring unit. Now, if you're not sure of how to do that, this right here, that's fine. Just multiply out. I'll do a quick little demo here of how to multiply. You're going to multiply just like we did before. Use the box method. Make sure you take the symbol with it. So you have 16. You have a positive 4i. You have a negative 4i. And you have a negative I times I. This right here, let me shift this up just a little bit, is equal to a negative I squared. But wait, don't we know what negative I squared is? No, we know just what I squared is. So that means I have negative, and this I squared is equal to a negative 1. So that means that this right here, I just want to make sure that this I squared is this negative 1. We just happen to have a separate negative, this one, out in front, that's going to affect our answer. So when we do this here, let's go ahead and shift this. I'm going to rewrite the fraction one more time. In our numerator, we have 3 times 4, which is 12, minus 3, I times I, which is I squared. I'm going to put that all in parentheses. In our denominator, we're going to have 16 minus, and again, I squared is negative 1. I also have an I squared in the numerator. We'll change that in a little bit. That means a negative and a negative make a positive. Same thing here. Rewriting the fraction one more time. I have 12i minus 3, and then I squared we said was negative 1. In our denominator, I have 16 plus 1. So I have 17 in our denominator, and in our numerator, I have 12i plus 3. This is multiplication. Now, if you want to switch it and to have it be 3 plus 12i, you can. Just make sure if it's negative that you take the symbol with it. This is all divided by 17, and this is your final answer. Let's do one more really quickly on this one here. Example 2. Let me shift down my paper. For example 2, let's do something with two binomials. We'll have 7 plus 4i, and we're going to have 2 minus 5i. Multiplying top and bottom by the conjugate of the denominator, not the top one, the bottom one. So I have 2 plus 5i and 2 plus 5i. Why plus? Because this is a minus, therefore we got to do a plus. In our numerator, it looks like we're going to FOIL because we have two binomials that need to be multiplied. In our denominator, we're going to have, remember we have a squared minus b squared. So what is our a? Our a is 2, so we have 2 squared. Our b minus, in this case our b, let me do a jagged little line here. is 5i, and that's 5i squared. Not just the I, but the 5 as well. So in our numerator, we're going to keep it factored out, not multiplied, just for a little bit longer. So in our numerator, 2 squared is 4, minus, now this right here, this is 5i times 5i. That means you have 5 times 5, and you have I times I. Well, we know what 5 times 5 is. That's 25. We also know that I times I is I squared. But wait, there's more. I squared is negative 1. This is all multiplication, so that means this is a negative 25. So be careful, you guys, because this negative 25 goes inside a bubble. Do not forget this bubble. And that is because you have two negatives that make a positive. If you forget that bubble, then you're going to think that negative's already there when it is not. So an easier way to think about it is this symbol right here after you simplify will always be a positive. So you have 4 plus 25. We still haven't done anything with our numerator. That's okay. We're going to do it in our next step. I'm going to off to the side create a box method. So I have 7 and 4i. I have 2 and 5i. All of these are positives. 7 times 2 is 14. 2 times 4 is 8. Then I have an I. 7 times 5 is 35. Then I have an I. And I have 5 times 4, which is 20. I times I, which is I squared. Shift that up so you guys can see better. We know that I squared is negative 1 in a bubble. So that means 20 times negative 1 is negative 20. Simplifying this out, I'm going to do a thinking bubble here. I have 14 plus 8i and 35i minus 20. So we're going to have to combine things that don't have i's next to them and then things that do have i's next to them. We're going to have to simplify that out. So we have 14 minus 20. Oops, I'm using a calculator and I typed in 200 instead of 20. I have negative 6. And I have 35 plus 8, which is 43i. So bringing this back up here, in my numerator, I have negative 6 plus 43i. In the denominator, I have 25 plus 4, which is 29. And it doesn't have to look pretty, but this is your simplified answer. All right, beautiful people, thank you so much for watching. I will see you in the next video, and I hope you have a fantastic day.